Hi guys, good morning. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, I'm Dr. Joseph or Mr. Explicit. So we are still discussing chemical and physical changes, alright? So sorry regarding the previous video. While the video was going on, or while the class was going on, my phone fell down, so I'm so sorry about that. Because I wasn't able to finish it because of the interruption, okay? But in today's class, I trust to finish both chemical and physical changes, alright? I told you in our previous class that if you are preparing for 2024 JAM, that is UTME, Post-TME, NECO, GCE, NAPTED, WAEC, and nursing examinations. So you can just chat me up on this number 6011 5375 so that I can add you up to my WhatsApp group. Okay, so in our previous class, we said that chemical changes are changes that are irreversible, new substances are formed, the mass of the substance changes, and it requires a large amount of heat in order for it to change from one state towards another. We also gave some examples of chemical changes before my phone fell down. We said that the example of chemical changes are one, the addition of water to calcium carbide. All right, let me do it again. Addition of water, the addition of water to calcium carbide. The addition of water to calcium carbide is a chemical change. I said we have, if calcium carbide is reacted with water, I told you guys it will form an ethyne plus what? Calcium hydroxide. Alright, so we did illustrate this very equation in our previous class, and I told that number two, neutralization reaction. The reaction between an acid and a base, neutralization reaction. I told you it is a reaction between an acid and a base to produce salt and water only. And I said if H2SO4 is reacted with sodium hydroxide, this same H2SO4 when it's reacted with potassium hydroxide, alright, if HNO3, which is also called aqua fortis, when it's reacted with sodium hydroxide, alright, when HCl, that is when this same HNO3 is reacted with sodium hydroxide, alright, if HCl is reacted with sodium hydroxide, then this HCl is reacted with potassium hydroxide. So what will be the byproduct? Alright, you will have, it is a reaction between an acid and a base, right, to produce salt and water only. Alright, look at what I have here. H2 will react with water, while this will react with this. I'll be having what? NaSO4. But this kind of compound does not exist in the world of chemistry. So it is written like this and not like this, okay? So looking at what we have here, the equation is not balanced. For me to balance it, I will have to place 2 at the back of this place. Automatically, I now have 4 hydrogen. That is 2 plus 2, 4. But I only have 2 here, so which means I will have to place 2 at the back of this place. That automatically balances the equation. Same thing is applicable here. I'll be having potassium plus, then plus, that is potassium 2. Then I have 2 moles of what? Water. So I'll put 2 at the back of this place. This is potassium sulfate. That is potassium tetra also sulfate what? 6. Sodium tetra also sulfate 6. So that is for that. Then if HNO3 should be reacted with potassium hydroxide, what am I going to have? I'll have KNO3 plus what? Water. KNO3 plus water. Is the equation balanced? 2 hydrogen, 1 nitrogen, 1 nitrogen, 3 plus 1, 4. 3 plus 1, 4. So it is what? Balanced. So what do I have here? I'll have sodium, that is sodium triazonitrate 5, that is NaNO3 plus what? Water. You see, and that is, it is a reaction between an acid and a base to produce salt and water only. Alright, so what do I have here? This hydrochloric acid, when it reacts with this, I have sodium chloride and what? Water. Sodium chloride and water. The same thing is applicable here, potassium chloride and what? Water. So neutralization reaction is an example of what? A chemical change, because all of these products cannot be reversed back to their what? Reactants. Take note of that. It is very, very important. All right. Number 3 example of chemical change is the burning of wood. Burning of wood. When wood is burned, what will happen? Ashes or charcoal are produced. Now, if I may ask you, can you convert ashes and charcoal back to wood? It's not possible. So the reaction is what? Irreversible. And now for wood to be burned to become charcoal and ashes, it means that it requires a large amount of what? Heat, just as initially what? Established. Number 4, precipitation. In which if a solution is what? Formed. Okay. Number 5 another example is the souring of milk. The souring of what? Milk. Alright, if milk sour, you must be converted and go back the way it did. As soon as milk sours, it cannot be converted to the way it used to be. Okay, it has spoiled, so there's nothing you can do about it. Number 6, what do you have? Number 6, the melting of metals. The melting of metals in acid. Melting of metals in acids. When metals are melted in an acid, all right, they cannot be converted back to their metallic states. All right, when it forms a solution, you cannot convert that melted metal to the way it used to be. Okay, take note of that. Is there any other point? Yes, number 7. All right, decomposition of food. Example is what? Digestion. Okay, so all of these are chemical changes. Another example is putrid. This marker. Another example is putrefaction. Like, these are chemical changes. That is the rotting of leaf. When leaves get rotten, they cannot be converted to the way they used to be. Irreversible changes. Number 9, very popular example, the rusting of metals. Rusting of metals. All of these are chemical changes. They'll ask you, which of the following is a chemical change, or which of the following is a physical change? So with this, you should be able to give examples of physical and chemical changes. So we are done with chemical changes. The next one is physical changes. I don't write on the board because it is much more easier than the chemical changes. What is a physical change? All that I've said regarding chemical changes, when they are reversed, you now have what? Chemical changes. We said that chemical changes, they are changes that are irreversible. Physical changes are reversible. We also said that new substances are formed in a chemical change, but in physical changes, new substances aren't formed. We also said that in chemical changes, the mass of the substance changes, but in physical changes, the mass of the substance does not change. We also said that in chemical changes, large amount of heat is required for it to change from one state to another. Physical change, little amount of heat is required for it to change from one state to another. So what are examples of chemical changes? The addition of sodium chloride to water. The addition of sodium chloride or potassium chloride to water. Of course, both of them are salts. when salts are dissolved in water, I have what? Salty solution, okay? I can get back my salt by sacrificing the water through a process called what? Evaporation. They'll ask us, I don't know how they place this question at all. And sodium chloride crystals can be gotten from seawater by dash. It is what? Evaporation. Because the salt present in the solution when the water molecule, when the water is heated, the water is sacrificed. We call this what's it called now? We call it what? Sacrificing the water, and I'll get salt back. So it means that the reaction is what? Reversible. It can be reversed. That is what what's it called now? Addition of sodium chloride or potassium chloride to water, or addition of salt to water. Another example of physical change is melting. Process whereby a solid changes to what? Liquid. Of course, melting, if that is, for example, the ice melts to liquid, right, and now have water, right? But when that water undergoes freezing or solidification, that water becomes what? Solid. So you see, it is what? Reversible. All right. Same thing, condensation, where it is a process whereby gaseous molecule form what? Liquid. Once that liquid is produced, when it undergoes boiling, that same liquid goes back to what? Its initial state, which is what? Gaseous state. You see, it is reversible. What about sublimation? Process whereby a solid molecule changes to gas without passing through the intermediate liquid stage. It can also be reversed from gas back to solid through desublimation or deposition. We also said that in our previous class, we gave some examples of solids that exhibit such phenomenon. We said naphthalene, benzoic acid, quinines, toluenes, iodine, camphor, ammonium chloride, dry ice, that is carbon dioxide. All of these can undergo what? Sublimation. So sublimation, freezing, melting, condensation, vaporization, that's liquid to gas, all of these are physical changes. Thanks for watching. Do have a wonderful day. If you have learned something in this video, please endeavor to subscribe, like, share, and comment so that when I upload our new content, you'll be notified by YouTube. Do not forget to chat me up on 091 60 11 53 785 so that I can add you up to my WhatsApp group. Do have a wonderful day.